Hello everyone. So today we are going to be talking about rate of change. So in the first page of your notes it has interval of increase and decrease. Well, we've already done this, okay? So if you guys want to review this, read over the first page, check out this little illustration and try your best. And if you need to, you can definitely send me a screenshot of what you've done and I'll let you know if you've got it right or wrong. But we're not going to go over this again, okay? Instead, we are going to go all the way to number 7 for average rate of change, okay? Average rate of change is just another way to say slope. And we find slope using y2 minus y1 divided by x2 minus x1, okay? That's how we do it. So let's take a look at number 7. I'm going to zoom in a little bit. There we go. And we're going to find the average rate of change from x equals 1 to x equals 2. So the way that we're going to do this is we're going to go to x equals 1, and we're going to find that point. And that's going to be 1, 1. You guys see that? And then we're going to go to x equals 2. So that's going to be the point 2, 4. All right? So now we have our y2 and our y1, so that's going to be 4 minus 1 over 2 minus 1. So that's going to be 3 over 1. So then our slope is 3. The other way you could do it is, since we have these 2 points, just count 1, 2, 3 over 1. So that's plus 3 plus 1. Rise over run equals 3 over 1, which equals 3. Okay? So those are the 2 ways to do it, for that one anyway. Graphs are definitely easier to find the slope from. Alright, but now if we have a table and we're looking for the interval 1, 4, these are x's. Okay? So we're going to go from 1 to 4. So look at your point, 1, 1, and 4, negative 11. Okay? So that is going to be negative 11 minus 4 over 1. Whoops, I did something wrong. Yes, I did. Whew, goodness gracious. Sorry, guys. That's going to be negative 11 minus 1 over 4 minus 1. So that's going to be negative 12 over 3, which is going to give us negative 4. Sorry for the pounding in the background. The other way you can do it is how do you go from how do you go from 1 to negative 11? That's going to be negative 12. How do you go from 1 to 4? You add 3, okay? And then negative 12 over 3 will give you negative 4. So those are the 2 ways you can do it. Alrighty. Now, if you are given a function and told to find the average rate of change, this can be a little bit more tricky because we have to find our points. So these are our x's. And what you're going to do is you're going to put it into your calculator. So I do not have a yellow calculator with me. Oops, let me zoom out. So what you would do is go to table, you would input this function, and then you would find your points. So I have to do mine a little bit differently, but hold on. Alright, so I'm at my table, and I need the points 2. So that's going to be 2, 8, and then 3, 13. Okay? Alrighty. So now we need to use our slope formula. So that is going to be 13 minus 8 over 3 minus 2. 13 minus 8 will give me 5. 3 minus 2 gives me 1. 5 divided by 1 gives me 5. And so that is your average rate of change. All right. For the next one, we are going to be comparing this table to this function. And we need to find which one has the greater rate of change over our interval 1 to 4. So, first, what type of function is this? This is going to be exponential. But don't worry, that doesn't actually matter, okay? So we're going from 1 to 4. Okay, so how do you go from 1 to 4? You add 3. How do you go from 3 to 81? That's going to be 78. Okay, the other way you could have done this, 81 minus 3 over 4 minus 1. And that would give you 78 over 3, which is going to give you 26. And this would also be 78 over 3. Okie doke. Alrighty. For this one, we need to put it into our calculator. Whoops. There we go. To get our points. Okay, so I'm going to do that really quick. Again, my calculator looks a little bit different, so I don't want to confuse you guys by showing you guys how I'm doing it, because it's different from our yellow calculators. Alrighty, so here's your table, and we're going to go to 1, and that's going to be 3. So we have 1 comma 3, and then we're going to go down to 4, which is 45. And we have to use our slope formula, y2 minus y1. So 45 minus 3 divided by x2 minus x1, 4 minus 1, which is going to give us, 42 over 3, which is going to give us 14. So, but don't forget, we are comparing. So which function has the greater? Function A or function B? Function A is greater, because 26 is greater than 14. Okay. Let's move on to our last page. Alrighty. So we are going to use the graph to the right to answer our questions below. Which graph has the lowest y-intercept? So remember, our y-intercept is where it crosses the y-axis. So for our line, for A, crosses at 4, and then for B, it crosses at -1. So graph, I'm getting A and B from these letters right here. So B has the lowest y-intercept. And what is that? Y equals -1. Okie doke. Alrighty. And then, which graph has the greatest rate of change over our interval, -8, -6? Okay, so we need to find those points. So I'm going to do graph A, which is our line. So -8, 0, and then -6, 1. So we need to do a rise over a run. We could also just do this. So that's going to be rise 1 over 2. You could also do the 1 minus 0 over -6 minus -8 to get 1/2. Okay. And then for graph B, -8 is still right here to -6, be right here. So that would be 1, 2, 3, 4, 5 over 2. You could also find those points. The points were -8, 0, and -6, 5. And so then that would be 5 minus 0, over negative 6 minus negative 8. Negative negative turns that positive to give us the 5 over 2. So either method will work. So which one has the greatest rate of change? If you're not sure, put it in decimal form, okay? So, whoops, let me see if I can get my calculator up. All right, so 1/2 will give us 0.5, okay? So this one equals 0.5. And then 5 over 2 will give us 2.5. Therefore, graph B has the greatest rate of change. Alrighty. And then finally, consider the functions graphed. Over which interval below would the two graphs have the same average rate of change? So we have the possibility between 0 and 1, okay, 0 and 4, negative 2 to 2, and negative 2 to 0. Alrighty. So I'm going to go ahead and teach you guys the trick for this question. In order to find the interval where the two graphs have the same average rate of change, they need to have the same points, okay? So for 0, okay, oh, they have the same point, cool, so we like that. But 1, they have different points, so it's not going to be 0 to 1, okay? And then let's look at C. Negative 2. Well, that has a point there, and that has a point there. So negative 2 is not great. Let's check out 2 just in case. Nope, different points. Okay, we already saw that negative 2 doesn't work, so that's a big fat nope. And then if we go to 4, hey look, they intersect here as well. Alright, so if you don't believe me, let's try it out. So for our line, okay, our line. If I'm looking at the point 0, and then I get negative 2, and then I look at the point 4, I get 2. Okay, so if I find that slope, it's going to be 2 minus negative 2 over 4 minus 0. And that's going to give me 4 over 4, which gives me 1. Okay, and then if I look at the quadratic, I'm going to use a different color other than orange. So for the quadratic, I'm going to have point 0, negative 2, and then 4, 2. And that's going to be 2 minus negative 2 over 4 minus 0. You see where this is going, right? Positive, positive, 4 over 4, which equals 1. Okay? So whenever you get the question that asks which ones have the same average rate of change, look for the same points. Okie doke. Alrighty. And that's the end of our notes for today. Good job, guys.